Let's see the next application of dynamic programming, that is matrix chain multiplication. Right? People use to say MCM, matrix chain multiplication. Right? Let's see this. What is this problem? Right? I will explain with the help of numerical example. See this one. See the first problem. Example 1, matrix chain multiplication, example 1. See this one, A matrix of size 2 by 3, B matrix of size 3 by 4. A matrix of size 2 by 3, B matrix of size 3 by 4. Two matrices A and B. A matrix size 2 by 3, B matrix size is 3 by 4. See this one, these two are same. Why these two are same? To multiply two matrices, there is a condition. First matrix number of columns is equal to second matrix number of rows. Some people are asking, sir, why are you doing matrix multiplication? See the topic name, matrix chain multiplication. So in this problem, we are going to discuss about matrix multiplication, right? So matrix chain multiplication. See this one. Right? I am taking the first example, A 2 by 3, B 3 by 4. The reason why these two I took same is, if you want to multiply two matrices, these two should be same. Right? Next one, see the next one. C is equal to A into B, I want to do. C is equal to A into B, I want to. Can you say what is the A size? 2 by 3. B size 3 by 4. Right? I think if you cancel both, C size becomes 2 by 4. So I want to multiply A and B. Resultant matrix is C of size 2 by 4. The reason is these two are cancelled, then automatically these are right. So if anyone asks you from today onwards, if you multiply two matrices, resultant matrix size what? If anyone asks you, nothing there. First matrix number of rows, last matrix number of columns. If you multiply two matrices, resultant matrix size how much? Which is equal to first matrix number of rows, last matrix number of columns. The reason is in between all the things will cancel each other. So C matrix size is 2 by 4. Right, let's see the next one. Can you, now I think from this one, let me do rough diagram. See the rough diagram, how it look like rough diagram. See this one, A 2 by 3. See this one, 2 by 3, 2 rows 3 columns. B 3 by 4. It is the 2 by 3, it is the 3 by 4. That's okay. Now see the answer. C is equal to A into B, as you know. What is the C size? 2 by 4. That is also you know. Now let me write. C is equal to 2 by 4. Right, now can you help me one small, how to get this element? C matrix size is 2 by 4, it's okay, right? 2 by 3, 3 by 4, 2 by 4, that's fine, I am okay with that. That is the 3 by 4, it is the 2 by 3, right? Everything fine. C matrix size is going to be 2 by 4. Can you help me know what is the first element? Right? How to get the first element? So everyone know, if you want to get the first element, see this one. If you want to get the first element, this is the way. How? First element means what? Right? First row, first column. In the C matrix, first row, first column element I want. How to get? If you want C matrix, first row, first column, everyone know what is the answer? First row, first column. You have to multiply both. So if you want in the C matrix, first row, first column element, now first row, first column, you have to multiply. Can you see how to multiply? See this one. This one should be multiplied. First one multiply. Second one multiply. Third one multiply. Third one multiply. And one more thing I want to ask you, see this one. These three multiplied with these three. So can you say what is the meaning of these three? Number of columns. What is the meaning of these three? Number of rows. That is the condition. If you want to multiply two matrices, first matrix number of columns, second matrix number of rows should be equal. So first one, second one, third one. Supposition that one more is there, one more column is there. You want to multiply but row not there, problem will come. So that is the reason these two should be equal, everyone know. So can you help me now? How to get the first element? How to get the first element here? If you want to get the first element, first one multiply plus second one multiply plus third one multiply, right? Like that. So first one multiply plus second one also multiply, third one also multiply. I think to get this one, 3 multiplications required. How to get this one? First row, second column, first row, second column, first row, second column you have to multiply. I think same, 3 multiplications required. It is also same, first row, third column multiply, it is also 3 multiplication. First row, fourth column, it is also 3 multiplication. Similarly, right, how to get this element? What is the answer? Second row, first column, right? Same, 3 multiplication. This is also 3 multiplication. This is also 3 multiplication. This is also 3. Now let me ask you one small line. Can you help me now? Resultant matrix C contain how many elements? Right? 2 into 4 elements. Resultant matrix C contain 2 into 4 elements, which is going to be 8 elements. That is fine, 8 elements, that is okay. Next one, can you help me one? C matrix contain 2 into 4 element means 8 element, that is okay. Next one, 8 into 1 element required 3 multiplications. 1 element required 3 multiplications, which will goes to 8 3s. What is the answer? 24 multiplications. Now see the final line. What I discussed until now, let me explain once. See this one. Topic name is matrix chain multiplication. To explain that problem, right? To explain this particular application, I want to give one example I written. What is that one? A matrix of size 2 by 3, B matrix of size 3 by 4. I took both as equal. This is also 3, this is also 3. The major reason is to multiply 2 matrices, right? First matrix number of columns, second matrix number of rows should be equal. So I took accordingly. So next one. After completion of this, I got to know that C matrix size is 2 by 4. Why? Right? If you multiply 2 matrices, resultant matrix size is completely based on first matrix number of rows, last matrix number of columns. So like that. Now, resultant matrix C, if you observe, right? C matrix contains 2 by 4 element. Every element required 3 multiplications totally, right? 24 multiplication. In the matrix chain multiplication, our goal is going to be to multiply the given matrices. How many number of multiplications are required? I think 24 multiplications required for this problem. In this problem, we are multiplying the matrices. Next one, to multiply the matrices, how many multiplications required? We are calculating that only. So to this problem, to multiply A and B, A of size 2 by 3, B size 3 by 4, to get the C of size 2 by 4, 24 multiplications required to this problem. What is actually this problem? In further things, right? In further problem, we will get to know clarity. Right? I am thinking, right? Example 1, you are okay. I am thinking example 1 you are comfortable, right? This is example 1. So if anyone having small doubt also, in the further examples you will get the more clarity. Right? Let's go to the example 2. See the example 2. A 2 by 4, B 4 by 3, A 2 by 4, B 4 by 3. Now can you help me now? A 2 by 4, B 4 by 3. See this one? I think previous problem taken a lot of time. This is going to be very simple now. A 2 by 4, B 4 by 3. I think these two are equal. It's okay. Now see this one? C is equal to A into B. Can you help me? What is the C matrix size? What is the answer? C matrix size is 2 by 3. C matrix size is 2 by 3. What does it mean? 2 by 3 elements. Which will goes to what? 2 by 3 means 6 elements. Can you help me? Every element required how many multiplications? 4. If you want, you can check. So 6 into 4, right? Multiplications. Totally 6 4s 24. 24 multiplications. In the previous problem, I explained clearly that what is happening and all. Now directly I done. A 2 by 4, B 4 by 3. C is equal to A into B. C size is completely based on first matrix rows, last matrix columns. 2 by 3. So C contain 2 by 3 elements. C contain 2 by 3 element means 6 elements. Every element required 4 multiplications. Totally 24 multiplications. It is the example 2. Let's go to the example 3. So in this problem, we are counting to multiply given matrices. How many multiplications required? In this problem 24, previous problem also 24. Let's see the one more example. Example 3. Example 3. Make sure that clearly you follow this. From now onwards, please be comfortable at least now. A 1 by 4, B 4 by 2, C 2 by 3, D is equal to ABC. So if you multiply in the previous two problem, two matrices I took. Now in this problem, more than 2, I took 3, right? 3 matrices. These 3 matrices if you multiply, how many these 3 matrices if you multiply, you will get the D. So to get the D, total number of multiplications how many we have to calculate. To get the D, total number of multiplications how many, right? We have to calculate, we will see now, right? Let me calculate. D is equal to ABC. To get the D, total number of multiplications how many I am calculating. But one thing I want to ask you, please listen everyone. So ABC to get the ABC, right? To get the A into B into C, if you get that one, that is D, that is okay. To get the A into B into C, but everyone know 3 matrices at a time you cannot multiply. I want to multiply 3 matrices, but one thing I know, I cannot multiply 3 matrices at a time. So I know only one thing. What is that? 2 matrices multiplying only I know, but you want 3 matrices. See this one. So 3 matrices at a time you cannot multiply, but finally you can multiply. 3 matrices I want to multiply, that is my goal. But at a time I cannot do. I can multiply only 2 at a time. Right? Using 2, how to multiply 3 matrices, I will explain now. See this one? I think ABC you want to multiply, you cannot do directly, you have to go by 2 matrices only. So this is the way. See, first way is going to be, listen, this is the one way. What is that one? Only A, just to do BC, afterwards A into BC you do. That is the one way. 3 matrices I want to multiply, but I cannot do at a time. So how can I do it? 2 things only at a time I can do. So what is the first way? Only A, remaining you do. A into BC, right? Then that is the one way. You know how to multiply 2. After getting this answer, just to do A into BC. This is the one way. One more way. See the one more way? One more way is going to be, first you are taken only A remaining, next one, slowly increase. What is the meaning? AB, slowly, first only A remaining, now only AB remaining. So see, like this. So if, do you identify or not? Association is changing. What is the meaning? I think previously B going with C, now B is going with the A. Association is changing. Previously A alone, in this one A alone, now AB, C alone. Association previously, right? In these 2 things if you observe, B is first time going with the C, now B is going with the, right, A second time. Association is changing. This property of, right, mathematics is known as, you know very well, what is that one? Associative property. This is called associative property. Association is changing. Right? So I think in this one B and C, in this one A and B, means B association, but one thing is true, order is not changing. Some people are asking, sir, what is the meaning of order is not changing? The meaning is here also ABC, here also ABC. See the order. Is one in the given one also ABC, here also ABC, here also ABC. Order of this is one. I am not writing AB as BA. I am writing as AB only. The only thing is association is changing. What is the meaning? Brackets changing. Association changing is nothing but brackets changing. Matrix order not changing, only brackets changing. Only bracket changing, that is known as association is changing. So let me ask you, to multiply these 3 matrices, right, because of associative property, 2 ways are there. To multiply given 3 matrices, because of associative property, right, 2 ways are there. Right, some people are asking, what is the associative property here? Nothing, only first one remaining. Initially association to him very less. Why? Only first one remaining. Next only first 2 remaining. Suppose if I increase the association further, only first 3, only 3 only there. You have to divide these 3 matrices into 2 groups. First group, second group. But one thing, no group should be empty. Divide these 3 matrices into 2 groups. First group, second group, first group, second group. But every group should contain at least 1 matrix and one more order cannot change. So how I done here? Only first 1 remaining, only first 2 remaining. Association is slowly increasing. Initially is alone, afterwards 2, right? If at all possibility there 3. But when I take the 3, right, I think right group having 0 matrices. That is the reason only 2 possibilities. To multiply ABC because of associative property, 2 ways are there. First one, second one. Let's see first one what is happening, second one what is happening. Let's check here. Can you help me now? What is the A size? 1 by 4. What are the BC size? You know very well. What are the BC size? 4 by 3. You know this very well. How? First matrix, right? Rows, last matrix, column, 4 by 3. But the question here is going to be how to get BC. Let's check here. How to get BC? BC size is 4 by 3. It's okay. But how to get BC? Let me check here. Can you help me know what is the BC size? 4 by 3. BC size is 4 by 3. Now see the answer. BC size is 4 by 3. It's okay. Now BC contain how many elements? 4 into 3 elements. Which will goes to 4 3 is 24. 24 elements. Now can you help me now? BC contain 24 elements, it's okay. But every element required how many? I think 2 multiplications. 24 into 2 multiplications. Which will goes to 48 multiplications. So to get the BC, 48 multiplications required. So BC required 48 multiplications. If I want to do A into BC, first BC required. I calculated BC. BC required 48 multiplications. So why? BC size is 4 by 3. To get every element, 2 multiplications. Right? 24 into 2, which will goes to 48 multiplications. Can you help me now? So, to get the BC 48 multiplications, I am okay. To get the A, because of A already there, right? No need to do anything, 0 multiplication. To get the A, 0 multiplication. To get the BC, 48 multiplication. Some people are asking, sir, why BC required 48? Here not one person, see 2 people. You have to multiply. After multiplying only you will get the BC. Here A directly there. BC not there. B there, C there. BC not there. To get the BC 48. To get the A 0. Now can help you now. So if you want to multiply 2 matrices, first of all both required. I think left one available. 0 multiplications. Right one is available after some work. 48 multiplications already taken. Now I will do this one. If you want to multiply 2 matrices, first those 2 required. Yes, I think first one available directly, 0 multiplication. Second one directly not available, indirectly available. Indirectly means what? I done some work. After 48 multiplications is available. Now can help you now. A size 1 by 4. BC size 4 by 3. Can you say resultant matrix size? What is the answer? 1 by 3. Resultant matrix size is 1 by 3. So I think, can you say resultant matrix size 1 by 3 elements? Every element required 4 multiplications. 4 into 4. Total what is the answer? 3 into 4, 12. So see this one. Left one to get 0 multiplications. Right one to get 48. Combine 12. So what is the answer? 0 plus 48 plus 12. This is for left purpose. This is for right purpose. This is for combined purpose. What is the 48 plus 12? I think 60. So to do ABC, one way is going to be A into BC, which required 60 multiplications. This one, second possibility, let me try the second possibility. So to do ABC, one more possibility is AB into C. AB into C. Can you help me know what the AB size? 1 by 4, 4 by 2. What is the answer? 1 by 2. AB size is going to be 1 by 2. C size 2 by 3. AB size is going to be 1 by 2. C size is going to be 2 by 3. Right, fine. Next one. Now some people are asking to do ABC, one more possibility is AB into C, it's okay, right? So AB and C. First of all, you have to get AB. Let me get the AB here. Let me get AB here. Can you say what is the AB size? As you know, 1 by 2. So AB contain 1 by 2 elements, means 2 elements. Next one. Every element required how many multiplications? AB. 1 by 2 size, it's okay. Every element required 4 multiplications. So 1 by 2 into 4 multiplications, which will goes to 8 multiplications. So AB required 8 multiplications. So AB into C, if you want to do, first AB required for that 8 multiplications. C 0 multiplications. 0 multiplication. AB required 8 multiplications, right? C required 0 multiplication. Now you have to combine it. Can you say when you combine means if you multiply these two, can you say resultant matrix size 1 by 3. Every element required 2 multiplications. 3 into 2, 6 multiplications totally. So left purpose 8, right purpose 0, combined purpose 6 total. What is 8 plus 6? 14. So 14 multiplications. Can you help me now? To do ABC, how many ways? 2 ways. First way required how many multiplications? 60. Second way required how many multiplications? 14. Can you help me? Best one, overall best one. What is the answer? 14. Overall best one is going to be 14. I think now people got to know. Can you help me? What is the meaning of matrix chain multiplication? Matrix chain multiplication is nothing but you have chain of n matrices. Until now, see, in the first problem only 2 matrices. In the second problem only 2 matrices. Now here 3 matrices. You have chain of n matrices. In this problem maybe n means 3 maybe. chain of n matrices or chain of 3 matrices. When you have chain of n matrices, if you want to multiply all of them, because of associative property, many ways are there. Only two, one way. Previous two problem, if you want, you can check. Two matrices multiplying one way, two matrices multiplying one way. But when you are multiplying more than two matrices, because of associative property, many ways are there. The next question is going to be to multiply chain of n matrices because of associative property, many ways are there. The next question is going to be which way is better, which will take less multiplications. That will be our answer. So to multiply three matrices, we have two ways because of associative property. First way is taking 60 multiplication, second one is taking 14 multiplication. Best one is going to be 14. To this problem, answer is 14. What is the meaning of answer is 14? When you are multiplying three matrices because of associative property more than one way, which is the best way? Which will take less multiplication, that is the best way. So second one is the best one. Answer is 14. Because of answer is 14, the reason is 14 multiplications are enough. Next one is first path is given the best answer or second path? Second path means what? First AB with that C, you have to divide like this one. See this one, ABC. First AB, afterwards C, right? Like this. If you do like this, if you do like that, you got 14. If you do like this, you got 60. Best one is going to be second one. Can you help me now? If you keep parenthesis means bracket. If you keep parenthesis first way or second way, which is given the best answer? Parenthesis if you keep in the first way, 60 came. Parenthesis if you keep in the second way, you got 14. I think best one is second one. Because of this reason, matrix chain multiplication is another name. Another name is going to be matrix chain multiplication. Another name is going to be optimal parenthization problem. Optimal parenthization problem. Parenthization is nothing but parenthesis means brackets. If you keep bracket in which way, you will get the minimum number of multiplication, right? Optimal parenthization problem, which is nothing but because of associative property, so many ways are there to keep brackets. If you keep bracket in which way, you will get the less multiplication. That is called an optimal parenthization problem. If you keep bracket in which way, you will get the less multiplications. That is the meaning of this problem. Matrix chain multiplication, another name, optimal parenthization problem. What is the meaning? If you keep bracket in what way, you will get the less multiplications. Right? If you keep the brackets in this way, you will get the less multiplications. That is the reason it is called a matrix chain multiplication. Another name is optimal parenthization problem. Right? So I think if you keep the bracket like this, you will get the less number of multiplications. This is the example 3. I'm thinking almost you are comfortable. Let's go to the example 4. See the example 4. Please try to get this also. If anyone having small doubt also, see the example 4 also. Please at least be comfortable from now onwards. 1, 2, 3. First problem, second problem, third problem. Whatever you got until now, it's okay. Now almost you are okay with the problem. To get the more clarity, see the example 4. A 2 by 1, B 1 by 4, C 4 by 3, D 3 by 3. A 2 by 1, B 1 by 4, C 4 by 3, D 3 by 3. Next one, see this one, E is equal to A, B, C, D. E is equal to A, B, C, D. So we want to find out E, which is the combination of A, B, C, D. How to do that? I will explain. This problem try to get. Right? With this everything is fine. 4 matrices how to multiply. Because of associative property, many ways are there. Try to remember matrix. Listen everyone. Matrix multiplication don't satisfy commutative property, but it will satisfy associative property. Associative property is nothing but changing brackets. Associative property is nothing but changing brackets. When you say commutative property, matrix order you are changing. So in the case of associative property, matrix order you are not changing, brackets you are changing. So some people are asking, sir, how many ways of keeping the brackets here? We will see now. association slowly will increase. Some people are asking, sir, how many ways A, B, C, D can be done? I will try now. Very simple. Let's follow the right recursive behavior. So some people are asking, what is the meaning? This is the recursive behavior. See this one. Don't try all the possibilities at a time. Just follow in the top level properly, right? Bottom level also same thing will be done. That is the meaning of recursive behavior. Let's see how it is. 4 matrices, how to multiply. This is the way. Just follow like this one, right? Just divide these 4 matrices into 2 groups. Order you cannot change. Only brackets you can change. Divide these 4 matrices into 2 parts. Divide these 4 matrices into 2 parts. Some people are asking, I have to divide these 4 matrices into 2 parts in such a way that in every part at least one matrix will be there. Order also cannot be changed. Divide these 4 matrices into 2 parts. In every part at least one matrix should be there. Order cannot change. Some people are asking, sir, how to divide? That is the meaning of dynamic programming here. What is that one? Every possibility you have to cover. For 4 things I have to divide into 2 parts, that is fine. And one more, how to divide? In every group at least one matrix, cover every possibility. If you left one possibility also, means you are not covering every possibility. Let me cover all possibilities. See this one, this is the way. 4 matrices divided into 2 parts. Every part contain at least one matrix. Order cannot change. All possibilities you have to cover. If you don't cover few possibilities, that may be correct answer. Because of you are not covered, you may give wrong answer. Right? Let's see all the possibilities. See the one possibility? Just follow like this one. One possibility is going to be only first one remaining. Recursion will take care, don't worry. This is the one possibility. Divide 4 matrices into 2 groups. Yes, I divided. Every group contain at least one matrix. Order cannot change. Here also ABCD, here also ABCD. This is the one way. Some people are asking, sir, how will you multiply 3 matrices? Right? In the next level it will be done. You don't worry. Top level if you do properly, next level also same thing will be done. Don't worry about what the size of this, what the size. Simply divide into 2 groups. Every group contain at least one matrix. Every group contain at least one matrix. Divide into 2 groups. And one more. All possibilities you have to cover. Dynamic programming is covering all possibilities. So this is one possibility. So to do ABCD, one way is A into BCD. Right. See the one more way. Divide into 2 parts in such a way that every part contain at least one matrix. Order cannot change. And one more, all possibilities you have to cover like that because it is the dynamic programming. Let's see the another possibility. Slowly increase. Association is only first one. Next one is going to be first 2 remaining. So like that. If I want to go further, first 4 will come, but only 4 there. Divide 4 into 2 groups. Every group contain at least one matrix. And order cannot change. All possibilities you have to cover. This is the way. If you change the order, that is called commutative property. Matrix multiplication don't satisfy commutative property. It will satisfy only associative property. Fine. I think that is fine now. Now see that. Because of the recursion, next level also same thing will be done. Because of recursion, next level also same thing. Some people are asking what is the meaning of this, right? Again here, see this one. Again, one matrix, there is no requirement. See this one, 3 matrices. Again, same story. These 3 matrices divided into 2 parts in such a way that every part contain at least one matrix. Order cannot change. Let's do the same thing. What is the answer? Only B, C, D. Next one, only B, C and D. Let's slowly increase. Right, like this. It is the second. Some people are asking, sir, what about A? Right, after getting this one, whichever is the better one, with that I will do into D, this A. See this one, into A will be there. So complete this also. Whichever is the best one, take that only. Right? So what is the meaning? To do BCD 2 ways. Whichever will take less multiplication, take that. A into BCD. To get the BCD already best you done, with that A into BCD. So what is the one way? A into this one, A into this one. Instead of doing A into this one, A into this one, whichever is better you take. With that A into. Right? I think see this one. So this is the current. Right? And next one. Once again here. 2 matrices you know. 2 matrices you know. Again same. So what is the answer? Again divide. What is the first one? Only A remaining. Next one more. Only AB remaining. So here also same. A into BC to get this one. AB into C to get whichever is the best one you take with that into D. So here indirectly, directly two ways are there. This one into D, this one into D. Instead of doing that, whichever is the best one you take, into D you do. So totally indirectly, directly, here two ways, here one way, here also two more, totally five ways. To multiply four matrices indirectly, directly because of associative property, five ways are there. Five ways are there. Who are those five ways? A into this, totally two. It is the 3, it is the 4, it is the 5, right, like that, totally 5 ways. First level only 3, next level because of 3 matrices, right, divide like this, and one more. If I want to say according to algorithm, see this one, if I want to say according to this algorithm, right, I have to divide 2 also. Actually not required, according to algorithm you have to divide 2 also, until 1 will come divide. So 2 matrices, one way only divide, C one side, D one side. Actually not required, but until 1 you will divide. So CD, C left side, D right side, only one way there, right, only one way there, that is the reason no need, only one way means no need to divide, but according to algorithm, until 1 will come they will divide, right, fine, totally 5 ways are there. Now I am thinking that almost you are little bit comfortable, let's complete this problem, let's complete, you will get the full clarity, let's complete this, right. So these are the 4 matrices order, I think everything ready, let me check here. Please carefully follow this example. Previous problems you are okay means you are okay here also. If previous things not okay, then also no problem. This one please be comfortable. This one please be comfortable. Let's start one by one. Can I help you now? To get the B into CD, first CD required. To get the CD only one way. Can I help you now? To get the CD, first C required, already there. C already there, C 4 by 3 already there. To get the C because of already there, 0 multiplication. To get the D because of already there, 0 multiplication. So left one to get 0 multiplication, right one to get 0 multiplication, combined one. Let me check here, combined one. C 4 by 3, D 4 by 3, sorry, C 4 by 3, D 3 by 3. What is the resultant matrix? 4 by 3. So C contain 4 by 3 element. Every element required 3 multiplications. Total 4 into 3, 12, 12 3 is 36. So let me ask you, to get the CD, left 0, right 0, combined 1. What is the answer? 4 3 is 12, 12 3 is 36. This is the 36. Combined 1, what is 0 plus 36? How much? It is the 36. It is the 0. Let's do combined 1 here. Let's do combined one. So CD purpose 36 required, B because of only 1, 0 required. Let me combine. Can you say what is the B size? 1 by 4. What is the CD size? 4 by 3 we are already done. CD size. See, B size 1 by 4, right? CD size is going to be how much? CD. What is the answer? 4 by 3. 4 by 3. What is the overall size? 1 by 4, 4 by 3. What is the overall size? 1 by 3. To get the combined 1 into 4 means 12. So left 0 required, right 36 required, combined 1 12 required, total 48 required. Please check. B 1 by 4, CD 4 by 3, resultant matrix 1 by 3. Every element required 4 multiplication, totally 12. So left 1 0, right 1 36, combined 1 12, totally 48. Every time same story. So left one to do 48, to do BCD, left one, right one, 2 ways are there. One way given 48. Let's see the second way. Again BC, same story. What is the BC? Same story. What is the meaning? B and C. What is the B? If anyone little bit also difficulty there in this, you know how to multiply 3 matrices, you know very well. That's what you done in the previous problem you done. 3 matrices how to multiply? 2 ways. First way I done 48. Let's do second way. To get the BC, B required, C required. B required 0 multiplication, C required 0. It is the 0, it is the 0. Combined 1. What is the B size? 1 by 4. C size 4 by 3. Overall size 1 by 3 into 4. I think combined 1 12 multiplication. 0 plus 0, right? Combined 1 is 12. Overall is 12 for this. Can you help now? D 0. Let me combine it. So to get the BCD, to get the BC 12, to get the D 0, combined 1. What is the BC size? 1 by 3. What is the D size? 3 by 3. What is the overall size? BC is going to be 1 by 3, D is going to be 3 by 3, right? What is the overall size? 1 by 3 into 3, total how many? 9 multiplications required. So 12 plus 0 plus 9, 9 for combining. 9 for combining. What is the BCD overall size? BCD overall size is 1 by 3. 1 by 3, right? So this one, BC, this one, 1 by 3, D, 3 by 3, overall 1 by 3. So, right, next one, to multiply, 3 multiplications required into 3, totally 9. So left 12, right 0, combined one is 9, totally 21. So left one is 48, right one is 21, overall is 21 better, take 21. If anyone having small confusion also, 3 matrices how to do, you know very well, like previous problem. In previous problem, 3 matrices how you done, same thing I done. BCD 2 ways, one way 48, one more way 21. One more way 21, best one is 21. To do BCD, 21 required. Next one, to get the A, 0 required. Let's go for combine. Left one available, 0 multiplications. Right one available, 21 multiplications. Overall one how many? Can you see A size? 2 by 1. BCD size, what is the answer? 1 by 3. Can you see what is the overall size? Overall size, 2 by 3 into 1 multiplication, totally 6 multiplications. So 0 plus 21 plus 6, totally 27. So to do ABCD, one way is giving 27 multiplications. To do ABCD, right, 3 ways are there. To do ABCD, 3 ways are there. One way is given 27 multiplication. One more way, something else will come. One more way, something else will come. Whichever better I will take. But to do BCD 2 ways, in that best one 21. To do ABCD 3 ways, right? Until now 21 came. Let me do this also. Let me do this also, like that. Now one more small question I want to ask you. Maybe, I hope you remembered also. Let me say one small line now. Dynamic programming is slow. Starting or ending? Dynamic programming is slow. Starting or ending? Everyone knows starting only. Why? Everything is not available. In the case of dynamic programming, every time you will check, is it available or not? When you are solving any sub-problem, is it available or not, dynamic programming will verify. Right? But even though it is verifying, initially it is slow because in the table no one available. So dynamic programming is slow at the starting. If you want to get starting means what? In the tree, left side. In the tree left side, dynamic programming is slow because nothing available. But when you are moving from left to right slowly, many things are available. Some people are asking, sir, what are available? If you want, you can check, see this one. In this one, if you observe clearly, right? CD, see this one, CD there. So here no need to do CD again because CD already available. Dynamic programming is slow starting. Starting means left side. But when you are moving slowly to right side, many things are repeating. If repeating, dynamic programming is the best idea. See repetition there. CD here also, repetition, use it. Some people are asking, sir, to do A, B, C, D, first A, B required, next CD required. CD available, you will use it, right? A, B not available, then only compute. Can you help me now? In this tree, dynamic programming will do left side people, right side people. Everyone will do if not available. While doing dynamic programming in the tree, left side people, right side people, right? Whom dynamic programming will do? He will do everyone if not available. If not available, everyone will do. Right side people also he will do if not available. If he available, he will use it. Mostly left side people, no one available, he will do all. Right side people, few people only he will do because many things may be repeating. Left means first people. First people definitely not available because starting no one is available. But right side if you see, many people are repeating. So those people who are new, those only he will do. Right? If at all already there, he don't do. It's okay. Whatever you know, that's fine. Next one. Let me ask one small, Right. So I think one possibility I done, 27 I got. One more possibility, AB into CD. I think CD already you done. What is the answer? To get the CD, 36. Because left 0, right 0, combined is 36, overall is 36. It is the overall. Left 0, right 0, combined 36, overall value 36. Let's go for AB. AB not available. You will check is it available previously or not. Not available. You will do AB. Can you help me now? AB. What is the AB size? 2 by 4. So 2 by 4 into. Can you see every element required? 1 multiplication. totally 8 multiplication. So A0, B0 combined is 8, overall is 8. So to get the AB into CD, first AB required 8 required. Right, first AB required 8 required. Next one CD required 36. See the interesting answer. See the interesting answer. AB required 8. CD required 36. See, here itself 36. Here it is the overall is 27. Here itself 36. Here itself you can stop. See this one, A, B, C, D I am doing, right? But I got to know CD itself 36. If CD itself 36, afterwards adding few more things, it is more than 36. But this overall answer is 27. You can cancel it. So, first one is given 27, second is giving more than 27. That is the reason I am stopping. When you know that it is giving more than 27, don't do. Actually, I want to complete total, but I got to know, right? CD itself 36. Unnecessarily I done some work here. Right? So CD itself is 36, but here overall 27. So there is no need of doing this. I got to know that it is giving more than 27. Stop it. Let's come to this path. Let's come to this path. Can you help me now? So to do A, B, C two ways, A into B, C, A, B into C. Right? Let's see one by one. Can you help me now? If you want to do A into B, C, first B, C required, I think somewhere B, C available. See this one, 12. BC is 12. What is the A? 0. Let's combine it. What is the answer? A size. A size, please check 2 by 1. What is the BC size? 1 by 3. What is the overall size? 2 by 3 into 1. What is the answer? 6 multiplication. So, can you help me? What is the combined one? Right? Combining cost is 6 there. Overall cost, let me check. What is the answer? 18. 0 plus 12 plus 6, 18. Next one, AB into C. Let me check here. What is the AB? Already we done 8. So, that is the reason I done this. Right, that is the reason I done, because right, it may not be useful here, it may be useful further. That is the reason maybe. Right, let's take it as positive. Right, so actual unnecessarily I done, but this may be unnecessary here because this itself is 36, more than 27. You can stop. Unnecessarily I done this, but it may be useful here. So let me use it. So what is the answer? AB is given 8. What is the C? 0. Let me combine. What is the AB size? 2 by 4. What is the C size? 4 by 3. What is the overall size? 2 by 3 into 4 multiplication. 2 into 3 is 6. 6 into 4, 24. Right? Combining purpose 24 multiplication. But one thing is to, when you get 24, stop, because this is overall is 18. This is combining, right? Combining itself is 24. You have to add this 8 also. Best one is 18. So let's take 18. When you know that left one is better than right, you can stop it. So it is 18. Can you help me now? D, 0. Can you help me now? ABC size. When you say ABC size, what is the answer? First matrix rows, last matrix column. What is the answer? 2 by 3. What is the D size? 3 by 3. What is the overall size? 2 by 3. Into 3 multiplication. What is the 2 into 3? 6. 6 into 3, 18. Right? So this is 18. But one thing is to, already 18 there. 18 plus 18. What is the answer? 36. But this is only 27. Right? Here itself you can stop. Final answer is 27. When you know something is coming more than 27, stop. Left is 18. But when you combine it, 2 into 3, 6. 6 3 is 18. 18 plus 18, 36. But 27 already better there. Take 27. Everywhere. So try to minimize. If possible, minimize it. Do you believe or not? Left taken a lot of time. Right easily I completed, because most of the things are repeating. So if you want to check BC available somewhere. Next one, AB available somewhere. When you go to in the tree, rightmost part, most of the things are repeating. Suppose that left you will do everything because it is the starting, because nothing available. Right mostly everything available. Suppose that left nothing is available, you done everything. Right also everything new, nothing repeated. Then dynamic programming is not advisable. Dynamic programming is not advisable because right, every time new is coming. If every time is new is coming, why are you doing? Why are you storing? If everything is new coming, right, you are doing, you are storing also. If you store, you are not reusing it. What is the use? Every time doing, every time storing, and nothing is repeating, then why you stored? So dynamic programming is the best idea. Repetitions are there. I think to this one dynamic programming you can apply because lot of repetition. Right side mostly repetitions of left side. Repetitions of left side. Can you help me to this problem? To multiply these 4 matrices. Right? So how many ways are there? Totally 5 ways. But top level 3. Next level if you see, right, 2 ways. Here 2. So first one is given 2 ways, last one is given 2 ways, middle one is 1 way. Totally 5 ways. top level 3 ways. Below given 1 is given 2. This one also given 2. Means totally this is 2, this is 2, this is 1. Totally 5 ways. Out of 5 ways, best one is going to be 27. Now from the dynamic, listen everyone now. In dynamic programming, the most, right, I am repeating once again now. In dynamic programming, most important application is matrix chain multiplication. In the previous 10 years paper, if you see, almost like 5 or 6 times it came. Most probably in the next year also it will come. Please you take care. In dynamic programming, most important application is matrix chain multiplication. It came many times in the previous paper. Mostly numerical problem only will come. Something like this. Something like this will come. Right? Please be careful. And one more. Right? In the examination, maximum they will give 4 matrices only. Maximum 4 matrices. Maximum 4 matrices you will give. 4 or 3 or 2, something like that. More than 4 you don't give. Because of it will take a lot of time. If 4 given, don't do blindly. If 4 matrices are given, don't do blindly. The best thing what you do is, and at the same time don't do any shortcut also. 4 matrices are given, don't do blindly, right? And one more thing, don't apply any shortcut also. What you do is in 4, right? See, some 4 matrices are given, don't do blindly entire tree. So what you do is, A, B, C, D, 3 ways, here 2 ways, here 1 way, here 2 ways. Just to draw the tree first. After drawing the tree, listen, after drawing the tree, do left part. Do first one. So you got 27. Draw the tree first, it's okay. After drawing the tree, do first one. 27 you got, right? So just to draw the tree, complete the left one, you got 27. So one way is saying that answer is 27. What you do is, in the option you verify. Is there any 27? In the option 27 there, less than 27 not there, then answer is 27. In the option 27 there, less than 27 not there. If less than 27 not there, what is the purpose of going further? Because already you got minimum 27. Other people what they will go, I don't know. But in the available one, 27 is minimum, I already got. So select answer as 27. Suppose 27 there, less than 27 also there, then go to the second one. But while doing second one, please reuse it if it is already available, so that you can decrease a lot of time. Right? If you are lucky, both may be available. If you are unlucky, maybe one available. Worst case, maybe nothing is available, something like that. But because of the application of dynamic programming, definitely some repetition will be there. Worst case only do second one. Worst case only you do third one. If not available, in the option 27 there, less than 27 also there, then do this. Suppose assume that after doing this one, assume that after doing second one, I got answer as 15, assume. So first one 27, next 15 there, next 15, assume that. So what will you do is, in the option you check, 15 there, less than 15 not there, stop. This will be the answer. Supposing that 15 there, less than 15 also there, then go to third one. So worst case only do entire tree. In the best case, only left hand side is enough. Worst case, total tree enough. Right? Please be careful. Mostly this numerical example will come again. And one more thing. 4 matrices to multiply. Listen, 4 matrices to multiply using matrix chain multiplication property. Right? Then what is the answer? 4 matrices if you want to multiply. If you see this tree, see this one? 4 matrices, next level 3 matrices, next level 2 matrices, next level 1. What is the meaning? 4 level tree will come. To multiply, listen everyone now, to multiply 4 matrices using matrix chain multiplication story, right? So if you apply this algorithm properly, what is the answer? 4 level tree coming. 4 level tree coming. If you want, you can check. Fibonacci, first application is what? Fibonacci of n contain n level tree. If you want, you can verify. Fibonacci of 6 level tree. Next one, LCS problem, LCS of m comma n, m plus n level tree. M plus n level tree, right? Next one, 0 by 1 knapsack. What is the answer? N plus 1 level tree. Please check. Sum of subset 0 by 1 knapsack, both are same, right? So in every problem we are verifying, right, how many level tree coming, right? Now luckily starting itself I am taking the numerical example. You got to know that, right? See this one, matrix chain multiplication of 4 matrices will generate 4 level tree. 4 matrices become next level 3 matrices, 3 becomes 2, 2 becomes 1, right? I think 4 matrices if you want to multiply, 4 level tree will come. 10 matrices if you want to multiply, 10 level tree will come. And one more thing I want to ask you. 4 matrices if you want to multiply using this procedure, 4 level tree will come, it's okay, but not 4 level binary tree, 4 level ternary tree. See this one, ternary, I think, right, 3 children are there. Right, 3. Some people are asking, sir, first level 3 children, it's okay, next level only 2. What is the meaning of ternary tree? Maximum 3 children. Ternary tree means maximum 3 children. Right, I think 4 matrices if you give, 3 children will be there. Suppose if you give, if you want you can verify, 3 matrices are there, 2 ways. Some people are asking, sir, how? 4 matrices, how 3 ways? What is the answer? Only first one remaining. Only first 2 remaining, only first 3 remaining. So I think only first 4 is missing. Only first 4 missing. 4 matrices, first 1 remaining, first 2 remaining, first 3 remaining, first 4 no chance because one side is becomes gap. So 4 matrices, 3 possibilities. Suppose if at all here 9 matrices are there, first 1 remaining, first 2 remaining, first 3 remaining, I think 9 ways will come. If at all here 4, 3 ways. If at all here 5, 4 ways. If at all here 10, right, 9 ways are there. Suppose if at all here n matrices, n minus 1. So 4 matrices ternary tree, n matrices, n minus 1 array tree, which is nothing but, forget about the minus 1 plus 1, upper bound. If n matrices are there, n array tree will come. 4 matrices, 3 array tree, 10 matrices, 9 array tree, n matrices, n minus 1 array tree will come. Upper bound if you take, right, n matrices if you take, n array tree will come, not binary tree, n array tree. Right, some people are asking, sir, why n array tree? If you see all the applications, whatever you done previously, if you see all, most of the things contain, right, most of the things contain binary tree only. What is the reason? Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. I think 2 function call. Fibonacci of n going to be Fibonacci of n minus 1 plus Fibonacci of n minus 2. 2 function call, binary tree came. In the 0 by 1 knapsack, you may take, you may not take. 2 function call. If you go to the LCS problem, whenever no matching, you may decrement first one or you may decrement second one. So everywhere 2 function calls only. But here 4 matrices, right? See this one. This is a one way, this is a one more way, this is a one more way, which will goes to, I think, ternary tree. If at all n matrices are given, approximately n array tree will come. Now again I am asking you, matrix chain multiplication of 4 matrices will generate 4 level tree, which is the ternary tree. 4 level ternary tree will come. Suppose n matrices, n level, approximately n array tree will come. Please remember. And one more, many things are repeating also. You can go to dynamic programming also, right? Something like that. Please be comfortable, mostly numerical example will come. Until here enough. According to my opinion, by seeing the previous papers, until here enough. But I will complete remaining formalities also. Numerical examples only will come, mostly like this will come. And one more, whenever like this will come, don't do blindly all. Do left part, right? While doing right side, please reuse it. And one more, right side if really necessary, then only do. Otherwise, don't do. After getting first one, right? In the option 27 there, less than 27, not there, stop. 27 there, less than 27 there, then do this. While doing, reuse if anything available, right? Like that. And one more, lot of huge repetition there. Dynamic programming you can apply. And one more, 4 matrices to multiply, 4 level tree, 4 level ternary tree, 10 matrices, 10 level tree will come, 10 level 9 array tree, n matrices, n level tree, n level n minus 1 array tree will come, right? Fine. Let's go to the one more example. So to get the more comfortability from your side, let's go to the example 5. Please be comfortable at least here. For your convenience only I am doing this. See this one, only for namesake I am doing. A 1 by 4, B 4 by 1, C 1 by 3, D 3 by 2. Right? These are the given 4 matrices. Right? Let me do here. E is equal to A, B, C, D. So what is your goal now? Divide these 4 matrices into 2 groups. Think about top level. Don't think about total diagram at a time. 4 matrices divided into 2 parts in such a way that no part is empty, and one more, order cannot change, and one more, cover every possibility. Because of dynamic programming, you have to cover every possibility. One possibility also don't leave. 4 people divided into 2 groups. Every group contain at least one matrix. Order cannot change. And every possibility you have to cover. Let's start. What is the answer? I think slowly you have to follow like this one. What is the answer? Only first one remaining. For your comfortability purpose, I am doing one more example. Nothing new in this. Previous one, this one same. And one more. Only first two remaining. Only first three remaining. Next one. So this is the top level. Top level, whatever you done, right? Next level also same. That is the meaning of recursion. Let me do next level. B, C, D, same. What is the answer? Only B remaining. Only B, C remaining. Right? So like that remaining also. If necessary, we'll do the remaining thing. Right? Let's complete this problem. See the answer now. Can you help me now to get the B into CD? First CD required. Can you help me now? What is the CD? What is the CD? What is the answer? CD size 1 by 2. CD size is going to be 1 by 2. What is the B size? 4 by 1. That's okay. What is the CD size? 1 by 2. So 1 into 2. Can you help me now to get the one element? What is the answer? CD 1 by 2 into 3. So it will go to totally 6. So right, B purpose 0, CD purpose 6 required. B purpose 0, CD purpose we done 6 required. Let's combine it. If you combine, what is the answer? 4 by 1, 1 by 2. What is the answer? 4 by 2 into 1. What is the answer? 8. So 0 plus 6 plus 8. So this one 4 2 is 8. Combining purpose 8, left purpose 0, right purpose 6 total. What is the answer? 14. So to get the BCD, one way is 14. Let's see the another way. Can you help now? BC required. Check the BC. What is the BC size? 4 by 3. D size? BC size is going to be 4 by 3. D size 3 by 2. So what is the answer? 4 by 3, 3 by 2. Now that is the BC and D. That is okay. Can you say what is the BC size? 4 by 3. BC size is this one BC. 4 by 3 into 1. Which will goes to 12. See, this itself is 12. I think there may be chance of more also. Most probably, right, left only answer. 14 only answer. Because it is giving BC itself is 12. Definitely it is more will come. There is no need to continue further also. Only for namesake I will do. See, 12 this is already. B0, C0 combine is 12. So 12. What is the D? 0. Let's combine it. What is the answer? See, 4 into 2. Here itself 8K. Into 3. 8 into 3, 24. I think answer is going to be 14. 14 best. This is not okay. Here itself 12. Combine is coming. Right? 4 into 2. Right? What is the combine one? 4 into 2 is 8. 8 3 is 24. 24 plus 12. 36. I think 14 better. So BCD to get 14 is better. A0. Let's go to the next one. What is the A size? 1 by 4. What is the BCD size? BCD 4 by 2. What is the overall size? 1 by 2 into 8. Sorry, into 4. What is the answer? 1 by 2 into 4. Which will goes to 2 4 is 8. So 0 plus 14 plus 8. Right? 2 4 is 8. Total what is the answer? I think 22. Left one is 22. In the option 22 there, less than 22 not there, stop. 22 there, less than 22 also there, then go further. Right? If you are lucky, you can stop here. If you are unlucky, go further. Let me go further. Can you help? Is AB available? No. Let's do. Can you help? What is the answer? AB. AB size 1 by 1 into 4. So AB required 4. Can you say CD? What is the answer? 1 by 2. CD size is 1 by 2, it's okay, but CD already done 6. CD already done. Right, 6 there. Can you help me now? So left 4, right 6. Total how much there? 10 already over. Let's do combine. What is the answer? 1 by 2 into 1. What is the answer? 2. Totally 4 plus 6, 10 plus 2, I think 12. Comparing 22, 12 better. Check left 2. AB required 4. AB I think not there, I done 4. CD required 6. Combined required 2. 4 plus 6, 10 plus 2, 12. So 12. As of now, 12 better. Let's go further. Can you help me now? ABC into D. ABC into D. Let's check. How many ways are there? 2 ways. And one more thing, worst case only go here, right? Best case no need to go, because in the option you check 12 there, less than 12 not there, 12 there, less than 12 not there, stop. 12 there, less than 12 also there, then go further. Right? Only for namesake I am going. Mostly this will be the answer. Only for namesake I am. Can you see what is the first way? A into BC. What is second way? AB into C. Right? Let me check here. What is the BC? Already maybe we done. What is the BC? 12. See this one, BC 12. This is overall is 12. It is the BC 12. I think there is no use of going further. But one thing is true. In these two we are checking which is better. In these two, let me check here. In these two, which is better? Overall 12 is better. Definitely this option may not be the better idea. Who knows? It may be give best answer. That is the reason I am doing. Let me check here. BC 12, A0. Can you say combine? Can you give combine? What is the A size? 1 by 4. What is the BC size? 4 by 3. What is the overall size? 1 by 3 into 4, 12. 12 and 12, 24 is coming. But that is only 12. Basically, right, this may not be best option. Let's come here. What is the AB? Already we done. AB, 4. C, 0. Let's see the combined. What is the AB size? 1 by 1. What is the C size? 1 by 3. Overall, 1 by 3 into 1. What is the answer? 3. So 4 plus 3, 7. I think 7 better. This is 7 better. What is the D? 0. Let's see the combined. What is the ABC size? 1 by 3. ABC size is 1 by 3. D size 3 by 2. What is the overall size? 1 by 2 into 3. What is the answer? 6. 6 plus 7. What is the answer? 13. But this is 12. It is coming 13 but 12 better. So finally 12 is the answer. 12 is the answer. Almost, right? Almost third option also close to the answer, but 12 is better. Now from the matrix chain multiplication only numerically will come. There may be chance of 4 marks question. How it is? They will give 4 matrices. They will ask you. If you want to multiply these 4, minimum number of multiplications how many required? How many? 12. The next one, right? Question number 1 is going to be, they will give this. They will ask you to multiply these 4, minimum number of multiplications how many? Answer is 12. The next one is going to be which order you have to do? A, B, C, D. 12 is the answer, it's okay. But right, in what order I have to keep bracket so that I will get 12 as the answer. I think second approach this one. So A, B, C, D. Right, like that you have to keep bracket. If I keep bracket in which order, I will get the best answer like this. Best answer means how much here? 12. And one more, and one more. 4 matrices if you want to multiply, right, using this problem, how many level tree will come? 4 level tree will come. According to algorithm, this also you have to divide. 4 level tree. 4 level binary or ternary? 4 level ternary. Suppose if I give 10 matrices, 10 level, 9 array tree. If I give n matrices, n level, n minus 1 array tree, upper bound, n level, n array tree. And one more, repetition is there or not? Yes, you can go to dynamic programming. Right, so I think until here it is enough. 5 examples I given. Until here most probably enough. Right, but let's complete the remaining formalities, writing recurrence relation. Right, let me complete that also. You will see the time complexity and space also. Matrix chain multiplication problem, you understood very well. So I want to write the recursive program. If you want to write the recursive program, you should give, right, one name for that. Recursion means calling that itself. Right, let me write. See this one. See everyone now. Let's see this one. MCM of one name I should give. I am giving. Let MCM of 1 comma n. Let MCM of 1 comma n. Right? What is the meaning of this? Total whatever you understood. For that I given the name. MCM of 1 comma n. See this one. What is the meaning of 1 comma n? Right? 1 to n matrices are there, which are nothing but matrix M1, M2, M3 and so on. Matrix Mn. I am repeating once again. First matrix number is M1. Second matrix number is M2. Next matrix number is M3 and so on. Last matrix number is Mn. M1 matrix, M2 matrix, M3 matrix and so on. Right? N matrices are there. Right? MCM of 1 comma n. Whatever you understood, that only I am writing. MCM of 1 comma n is equal to, see this one. The minimum number of, you know very well, in the matrix chain multiplication we are finding minimum number of multiplication. See this one. Minimum number of multiplications MCM of 1 comma n is equal to minimum number of multiplications required. to multiply m1, m2, m3 and so on, mn matrices. Let MCM of 1 comma n is equal to the minimum number of multiplications required to multiply m1 to mn matrices. Right? This is the, see, when you want to write recursive program, you should give the one name I given. For the total story, I kept one name. What is that one? MCM of 1 comma n. The minimum number of multiplications required to multiply m1 to mn matrices. Right? This is the goal. Now let's see this one. Listen, you know everything you know. The only thing is whatever I said until now, I should write recursive program for that. I am writing. Until now I said numerical examples, right? Based on that I am writing the recursive program. Next one is going to be reconciliation, time complexity, space complexity, all the formalities I will complete. So if you learn previous things itself enough, mostly will give numerical problem, but I don't want to take risk and you don't want to take risk also. Let's complete everything properly. Let's complete everything properly, so remaining formalities also I am completing. See this one. So I am thinking that you are little bit fine now, right? From this let me write one small line. See this one, from this MCM of, one example I am giving, this one, from this, right? After this line, see the next line, MCM of 1 comma 4. What is the meaning? The minimum number of multiplications required to multiply 1 to 4 matrices. What is the meaning? To do m1 into m2 into m3 into m4, minimum number of multiplications how many I am calculating. MCM of 1 comma 4 is equal to, see the answer, MCM of 1 comma 4 is equal to, everyone know very well, 4 matrices, 4 matrices to multiply because of associative property. How many ways are there? Top level, see. Don't write everything in one place. Recursion means what? Right? From you to next level. So MCM of 1 comma 4 means the minimum number of multiplications required to multiply 1 to 4 matrices is equal to, right? 4 matrices are there. Top level how many ways? 3 ways. Can you say the first way? This is the first way. See this one, first one. MCM of 1 comma 1, only first one. And remaining. What is the next one? MCM of remaining means what? 2 to 4. Just to do this indicating that only A. This is BCD. Just to do A, do BCD also using recursion after getting both. Plus combine cost. This is the left cost. This is the right cost. This is the combined cost. Then total cost will come. So A into BCD, one way. Next one. MCM of first 2. Slowly, see, you have to divide these 4 into 2 groups. Left something, right something. But one thing, every group contain at least one matrix, order cannot change. So, first group contain 1, next group contain remaining. First group contain 2, next group contain remaining. Remaining means how many? MCM of 3 to 4. Plus this. One more. MCM of 1 to 3. Plus MCM of 4 to 4. So like this. Right, now see this one. Only first one remaining, only first 2 remaining, only first 3 remaining. Right, like that calculate. After calculating all, right, among all of them whichever is minimum, that is your answer. 4 matrices, right? Top level 3 ways. They may be internally called further. I am thinking that you are little bit okay. If anyone having small doubt also on this, right? See this problem. See this problem. Same thing. See, 4 matrices, 3 ways. Out of them, which is the minimum? Minimum of all. One is 12. See, so one is 22. Another one is 12. Another one is 13. 12 is better. So minimum of, right? Minimum of. So I written minimum of. Right? Fine. So I am thinking that you are little bit okay. Same thing. See, this diagram is equal to this one. The only thing is, right, this diagram and this one both are. The only thing is, right, I written here, right, horizontal direction. I written this one vertical direction. This is a vertical, see this one, right, 3 possibilities. Same thing I written, 3 possibilities in the form vertical direction. Tree format I written, normal way I written. This is the only difference. I am thinking that you are little bit okay, right? So let me say one small line pending. Let me complete that also. One small line pending. See this also. See, it is useful. That is the reason I am explaining. One small thing there. Just listen this also. Right? Assume. See this one. Assume M10 means matrix 10. Assume 10th matrix, right? 10th matrix. M10 means matrix 10. Assume 10th matrix rows are P9, not 9, P9. Assume 10th matrix rows are P9, columns are P10. I am not saying 10th matrix rows 9, I am not saying that. 10th matrix rows are P9, columns are P10. Assume that, right? If you are okay with that, if you are okay with this assumption, see the next story. Can you help me now? From this, assume 10th matrix rows are P9, columns are P10. If you are okay with that, then what about this one? Matrix number 98, rows how many? P97, columns how many? P98. If you assume this is right, from this I can say 98 matrix rows are P97, columns are P98. If you are okay with that, see the next one. If you are okay with that, can you help me one small line now? M5, M6, M7. If you multiply these three matrices, resultant matrix rows how many? Resultant matrix rows based on first matrix rows. Resultant matrix columns based on last matrix column. Can you help me now? What are the first matrix rows? P4, column P5. Can you say last matrix rows? P6, column P7. Can you say resultant matrix rows and columns? What is the answer? P4, right? And P7. Please be careful. M5 to M7 matrices, if you multiply, resultant matrix rows are P4, columns are P7. If you are comfortable with this, see this also. See this one. Mi matrix, Mi plus 1 matrix, Mi plus 2 matrix, and so on. Lastly, Mj matrix. Can you help me now? This resultant matrix rows how many? Pi minus 1. Can you help me now? This resultant matrix columns how many? What is the last one? Mj matrix rows are Pj minus 1, columns are Pj. So Pj. Right? Please be careful. This is the assumption. Assume this is right. If it is right, from this we can conclude M98, P97, P98 rows and columns. M5 to M7 matrices, if you multiply, resultant matrix rows are P4, P7. Mi to Mj matrices, if you multiply, resultant matrix rows are Pi minus 1, columns are Pj. Right, like that. Now if you are comfortable with this, see the interesting line. See this one. If you are okay with that assumption, see the interesting lines here. Listen everyone. Listen everyone now. So see this one. What is the meaning of this one? Right? M1 into remaining M2, M3, M4. This one M1, M2 into M3, M4. This one M1, M2, M3 into M4. Everyone now. Now can you help me now? So M1 matrix rows how many? P0, columns P1. Can you help me now? See what is this one? M2, M3, M4. M2, M3, M4 rows how many? Columns how many? Right? M2, what is meaning? P1. Next one, M4 means what? Columns P4. Same way here. What is the resultant matrix here? M1, M2 resultant matrix P0, P2. This one resultant matrix P2, P4. This one P0, P3. This one P3, P4. Right, like that. See this one. From all these things I got from here. That is the reason I assumed this. If I don't assume, I cannot write anything here. So instead of keeping the gaps and all, right, I kept, see this one, I assumed something, based on that I bring. If you are okay with this story, you are okay with this also. Can you help me one small line now? So this is the left matrix, this is the right matrix. I have to combine. Can you help me now? Right, what is the left matrix size? P0, P1. What is the right matrix size? P1, P4. Can you say resultant matrix size? P0, P4. Multiplications how many? Into P1. In the similar way, left matrix size P0, P2. Right matrix size P2, P4. Resultant matrix size, what is the answer? P0, P4 into P2. This will give size, this will give cost. This is the resultant matrix size. This is the resultant matrix cost. This is only for combine. So if you want to combine, left required, right required, combine. If you add all three, then total cost will come. Can you help me now? Left matrix size P0, P3. Right matrix size P3, P4. Resultant matrix size P0, P4. What are the right multiplications for combining into P3? So like that. So that is the reason initially I kept gap, because if I want to do this, right, this is required. Assume this, assume first one, from that all will come. So based on that I calculated this one. So out of all these things, whichever is better, right, that is going to be your answer. Can you help me one small line now? 4 matrices are there. How many people here? 3. 10 matrices are there. That is the reason I said to you, 4 matrices, 10 array tree will come. Next one, 10 matrices, 9 array tree will come. Suppose here n matrices, n minus 1 array tree will come. What is the meaning? Here n matrices are there. Here n minus 1 people. Out of n minus 1 people, finding minimum will take order of n time. Out of n minus, see, because of 4 only 3, which will take constant. Out of, if at all 4 people, here 3, out of 3 taking minimum, which will take constant. Out of, if at all 10 people, 9 people, out of 9 taking minimum, that is also constant. But if it is a n minus 1 people, out of n minus 1 people finding minimum, order of n, try to remember. In the case of 0 by 1 abstract, you may take, you may not take, 2 choices. You may take, find the answer. You may not take, find the answer. After getting both the answer, whichever is the best to, maximum of this will be the answer. So out of 2 people finding maximum, constant time. In the case of the Fibonacci, find the Fibonacci of n minus 1, find the Fibonacci of n minus 2. After getting these two, add them, which will take constant time. Adding will take constant time. 2 people adding will take the constant time. Out of 2 people finding the maximum, 1 comparison, constant. Next one, LCS problem. Whenever no matching, you may decrement first one, find the answer. You may decrement second one, find the answer. Whichever is maximum from them, that is the answer. Whichever is the maximum from them, that is the answer. I think out of 2 people finding the maximum, constant time. So if you see all the previous application, out of 2 people adding constant, 2 people adding constant, 2 people finding maximum constant, 2 people finding minimum constant. But here, out of n people, see, 4 means here 3. Here n means n minus 1. Out of n minus 1 people finding the minimum order of n time. Try to remember, in the previous all application, every function cost is constant. Because out of 2 people finding minimum, out of 2 people finding maximum, 2 people adding will take constant. But here, out of n people finding minimum, order of n. So in the previous problem, one function cost is going to be constant. But here, one function cost is going to be n. Some people are asking, sir, from where this story is came? From this only. This only came. Right? I written here 3 format. Vertical direction I written. Here I written the horizontal direction. Right? Other than this, nothing there. Some people are asking, sir, from where this came, right? So to get this particular story, I assumed this. Everything systematic. Whenever it is systematic, you will remember many days. If you don't do systematically, if you do by-hearted manner, you will forget immediately. So assume M10, matrix 10 contains P9 rows, P10 columns. If you are okay, M98, P97 rows, P98 columns. What about M5 to M7 matrices, right? P4 by P7 size will be there. Like that all. Alright, out of n people finding minimum, which will take order of n time. I am thinking that everything is absolutely fine. Like, let's write from this. Let me write the recurrence relation. Same thing only. Here numerical example I written in the form of numerical example. Let me write the recurrence relation. Very simple. See this one? Same thing in general. In general. Right, I am writing the recurrence relation. Careful listen, recurrence relation. See this one, recurrence relation. See this one, MCM of I to, same thing, MCM of I to j. What is the meaning? The minimum number of multiplications required to multiply Mi to Mj matrices. The minimum number of multiplications required to multiply Mi to Mj matrices. What is the first matrix number? Mi. What is the last matrix number? Mj. My to Mj matrices you want to multiply. Minimum number of multiplications how many? Is equal to. Answer is 0. If I is equal to j, means only one matrix there. I is equal to j means what? First matrix number, last matrix number same, means only one matrix. If only one matrix, the minimum number of multiplications required to multiply I to j matrices is going to be 0, because nothing is required. Only one is there with whom you will multiply. That is the reason 0 multiplication. If you have small doubt also, see this. Only one matrix, 0 multiplication. Only one matrix, 0 multiplication. Only one matrix, 0 multiplication. So that is the reason. Right? Fine. You are okay now. Now see the next one. If I is equal to j, this is a story. Supposition that this is fail. What is the meaning? Many matrices are there. See this one. Mi matrix. Mi plus 1 matrix. Mi plus 1 matrix. Mi plus 2 matrix. Mi plus 3 matrix and so on. Mj matrix. These matrices you want to multiply. Can you help me now? What you have to do? Divide into two parts. You have to divide mi to mj into two parts in such a way that, right, in such a way that no group is empty, and one more, order also cannot change. All possibilities. Order cannot change. All possibilities will be there. Two groups. No group is empty also. Then what is the answer? mi2 is one. mi is one. Ith place to somewhere you have to divide. You have to divide into two parts. Divide whatever way you want. But two parts will be there and no gap also. This is the answer. See this one? See, this is the answer. MCM of, carefully listen, MCM of, right? I2J matrices if you want to multiply, right, you have to divide into two groups. How? Just simply like this one. I2K matrices first multiply. Some K, what is the K? I will write. I2J matrices if you want to multiply, you have to divide that one into two groups, right? What is the answer? I2 some K you divide. I2 some K. I2J you want to multiply, I2K you divide first, right? Complete the I2K first. What is the next one remaining? MCM of remaining. What is the answer? K plus 1 to J you complete. So I2, see I2 some K. I2 some K first complete. Afterwards K plus 1 to J you complete, right? That is fine. Some people are asking I2K first, K plus 1 to J next, that is okay. But what is the K? See what is the K? Everyone know. All possibilities you have to cover. And one more, no group is empty also. And one more, right? Order also you cannot change. So this is the answer for all K. For all K. Where? What is the K range? For all K, where K range from? What is the K minimum? Minimum is I. Maximum is what? Not J, right? Less than J. So this one, less than J. So can you help me? What is the minimum K? All possibilities. What is the minimum K? I. Minimum K value I. Then what is the answer? I to I will come. What is the meaning? Only A remaining. If it is suppose that I to I remaining, I plus 1 to J is here. If the K is I to I left to remaining, I plus 1 to J, right? Supposing that some people are asking me, sir, if I take K value J, actually K should be less than J. If you take K J, what is the answer? I to K, here right group is no one there. That is the reason, less than J. Less than. For all K, every K, so many possibilities are. For all K where K range from minimum is I, maximum is going to be J minus 1, not J. If you want, you can keep equal also J minus 1. Because all you cannot keep in one group. Two groups should be there. Right, no group is empty and order also cannot be changed. Now what should I do? Can you help me? What is the first K value? First K value keep I, right, remaining I plus 1 to J. Next K value keep I plus 1, remaining is I plus 2 to J. Next K value keep I plus 2, I plus 2, I to I plus 2, I plus 3 to J. Like that, every possible K you do. So K value I plus 1, K value I plus 2, like that continue until K value become J minus 1. Then what is the answer? I comma J minus 1. This is going to be J to J, right? So each K value find the answer, but whichever will give less answer, that is minimum of. Every K one answer will come. Every K one answer will come, find out. K value I, one answer. K value I plus 1, one answer. K value I plus 2, one answer. Like that, find out all answers, whichever is minimum from them. That is the answer. And one more. This is going to be the story when if I not equal to J. So that is the answer for this. If I not equal to J, this is the story. If I is equal to J, only one matrix, 0 multiplication. If it is more than one matrix, so divide into two parts. Some people are asking, sir, only two matrices are there. Only two matrices are there, then also you have to divide. How? Can you help me? Only two matrices. Only two matrices A, B there. How to divide? Right? I think, what is the minimum K value? I. So what is the answer? A to A. Right? Remaining. What is the answer? B to B. So only one matrix here, 0. Only one matrix here, 0. Combined cost will be there. Let me write combined cost also. I forgotten. Let me write the combined cost also. What is the combined cost here? Plus. This is the left cost, this is the right cost, it is the combined cost. If I not equal to J, this is the story. Some people are asking, sir, how to find out combined cost? Everyone know. Can you help me now? Can you help me now? So if you see this resultant matrix size, what is the answer? Pi minus 1 into Pk. This resultant matrix cost, what is the answer? Sorry, this resultant matrix size, Pk into Pj. Please check. So every one of resultant matrix size is completely based on first matrix rows, last matrix column. First matrix rows Pi minus 1, last matrix column Pk. Here first matrix rows Pk, last matrix columns, right, Pj. Can you help me? Resultant matrix rows and column. What is the answer? Pi minus 1 into Pj. What is the multiplication? Into Pk. Right, like this. So divide the I2j matrices into two parts. How? I to k, k plus 1 to j. What is the k? Because of dynamic programming, all possibilities, all possibilities. But the only thing is, k value cannot be j, k value should be less than j. K value from I, right, less than j, like that. If I not equal to j, this is the story. If I is equal to j, this is the story. So this is the recurrence relation. Same thing. So if anyone having small confusion also, compare this. This is equal to this one. Here 4 matrices, I written step by step every one, but because of here many possibilities, all I written in some notation. For all k, where k range from I to j minus 1, because of dynamic programming, every possibility how to cover. Right, fine. This is the recurrence relation, right, for our problem. Can you help me? This recurrence relation will give time complexity, this recurrence relation will give time complexity, or what? Some people are asking what this recurrence relation will give. Everyone know recurrence relation can be written for many purposes, right? Some people will write the recurrence relation for a time complexity. Some people will write the recurrence relation for value. Some people will write the recurrence relation for something else. This is for what, right? This is for what is the purpose of this recurrence relation? I written also already. See, let MCM of 1 comma n is equal to the minimum number. It will give minimum number of multiplication. If anyone say recurrence relation, please write, right? First of all, what purpose you are writing, first define. MCM of 1 comma n indicate minimum number of multiplication. See, it is not for time complexity. Minimum number of multiplications required to multiply, right, M1 to Mn matrices. So this is finding minimum number of multiplication. If you want, you can check minimum number of multiplications will come. This is also minimum number of multiplications will come, right? Please be careful. This recurrence relation will generate minimum number of multiplications required. Internally calling, this will finally will give I to j matrices to multiply minimum number of multiplications. How many? That is the thing which is done by this recurrence relation. Recurrence relation can be written for anything. That may be time, that may be value, that may be multiplication, that may be comparison. Here minimum number of multiplications. If anyone is writing recurrence relation, first to define. You are writing recurrence relation, it's okay. But what purpose? I written already. This purpose. So see this one. This purpose I am writing the recurrence relation. If I write directly, you may be having confusion. I written the example first. See, like this. See, finally it is giving minimum number of multiplication. What is the answer for this one? If you want answer for this one, please say. Can you say what the first answer is given? K value 1, 22 is K. K value 2, 12 came. K value 3, 13 came. What is the answer? 12. K value 1 is 1. I think 1 to 1 remaining. K value 1, 22. K value 2, 12. K value 3, 13. Best one is 12. So let me write here. Same thing only. Same thing. This is given final answer. What is the answer? 22. This is given 12. This is given 13. Best answer 12. Best answer is 12. So out of n people finding minimum order of n time. So I am thinking that everything is absolutely fine here. I hope until now everything is fine. Let's see the next line. See the next line. MCM of 1 comma n will generate n level n array tree upper bound. Actually n level n minus 1 array tree. I am writing n array tree upper bound. Upper bound. Right? Some people are asking, MCM of 1 comma n will generate n level n minus, right? N level n minus array tree, n minus 1 array tree, but I written n array tree. Even though n minus 1 array tree, I written n array tree. So that is the reason upper bound I written. It's okay. Now see the next one. See the next one. This also you will listen. This also you will listen. Can you help me one small line now? First level, how many function call? One function call. One function cost is n. See this one. Minimum of these people finding n time. Minimum of n people to find out n time. So one function cost n time. Next one, second level, if you see, because of the n array tree, next level n function calls are there. Every function cost is n. Because one function cost is n. Here n functions are there. N into n, n square. Next one, what is the answer? In the next level, n square function call, every function cost is n. Continue like this. So what is the answer? It is the n power 1, it is the n square, it is the n power 0. First level only one function call. First level only one function call, n power 0 means 1. Next one n power 1 function call, right? Next one is n power 1 function call. Next one is n square function call. What are the lastly? Totally n levels are there. N minus n at n power n minus 1 function call, right? In these many levels into n. First level function calls n power 0. Next level function call n power 1. Next level function call n square. Last level function calls n power n minus 1. Every function cost n, right? Right. So normal previously we used to get a binary tree. Now we used to get an array tree. Other than this, nothing there. If you add all, then total cost will come. So if you see only first term, what is the one? Number of function calls. In that level, if you add all of them, total function calls will come. Right? Every function cost how much? N. Previously constant time for one function cost. Now here n time, because out of n people finding minimum. Now let me do this same thing here. So can you help in what are the first level of function calls? N power 0. Next level of function call n power 1. Next level of function call n square and so on. N power n minus 1, because 0 to n minus 1. What is the meaning? N level tree. These are the first level function call, second level function call, third level function call and so on. The last level function call. Every function cost is n, which will goes to totally. What is the answer? I think sum of n terms in the GP series. What is the formula? A into 1 into r power n power. How many terms? N minus 1 by r minus 1, n minus 1. Right? Outside there is a n. Right? One function cost is n. Right? N cancel approximately. What is the answer? Big O of n power n. Check small plus or minus 1. Don't think that much. So if you solve all of them, what is the answer? Again I am repeating now. A into 1 into r power n power. How many terms? N minus 1 by r minus 1, n minus 1. Right? Like that. Into n. This n cancel. Forget about minus 1 plus 1. Asymptotical I am talking. So n power n. So this is the time complexity. This is the time complexity. Right? So this is the time complexity of MCM problem. Let me write. Without dynamic programming, time this much. Without dynamic programming, time is n power n. Some people are asking, sir, why n power n? Previous all problems 2 power n. Now why n power n? Previously all binary tree is given. All applications previously if you see, all are given binary tree. But it is given n array tree. And one more, in all the previous problem, one function cost is constant because out of 2 people taking minimum, out of 2 people taking maximum, 2 people adding, which will take constant, but here out of n people finding minimum. So one function cost is n. So finally number of function calls are these, one function cost is n, overall is n power n. So without dynamic programming, time complexity this much. Some people are asking, why without dynamic programming? See, so many function calls are repeating. See this tree. Many function calls are repeating. If you want, you can say this tree. In this tree, if you observe, many function calls are repeating. See this one, CD repeating, BC also repeating, AB also repeating. Many function calls are repeating, so we will go to dynamic programming. If you count, total function calls are approximately n power n. Distinct only if you count, that is called dynamic programming. Let me go there. This is without dynamic programming. See, without dynamic programming, time is this. Can you help me now? What about extra space? What about extra space? Let me write here. What about extra space? Without dynamic programming. Without DP. Without dynamic programming. Right? What is the extra space? Let me check here. Extra space means what? Because it is a recursive program. What is the answer? Stack. Recursive programming, stack required. Can you say what is the stack? See this one. Without dynamic programming, extra space. Right? Means stack. Recursive programming, stack required. Can you say how much stack required? What is the answer? How many level tree came? N level. So n level stack. So n bytes. Dynamic programming means recursive program. So stack size n. N level tree. So I think stack size is n. This is without dynamic programming. Let's go to the next one. Everyone know? Let's see this one. This is a major line everyone know. Right? So in the above recursive tree, many function calls are repeating. See this one. In the above recursive tree. Many function calls are repeating. Not one or two, many function calls repeating. So we will go to dynamic programming. In the above recursive tree, many function calls are repeating, so we'll go to dynamic programming. When you say dynamic programming, what is the next one? Right? How many distinct function calls? Let me write now. This is the major line. Dynamic programming, this is the major line. What is the one? MCM of matrix chain multiplication. MCM of 1 comma n contain how many function calls? How many distinct function calls? How many distinct function calls? How many distinct function calls? MCM of 1 comma n contain how many distinct function calls? Dynamic programming to distinct function calls you have to calculate, right? Let's see. This is the answer for this. This is the answer. MCM of 1 comma n contain how many distinct function calls? That is the goal, right? Answer is very simple. Whenever MCM program is going on, can you help me now? This will change how many ways? MCM of 1 comma n contain how many distinct function call? Whenever it is going on, this will change how many ways? Right? Everyone now. 1 comma n, right? This one place, right? Whenever they are calling recursively, it may be 2 will come. It may 3 will come. It may be 4 will come and so on. It may become n. N ways it will change. Please check yourself. 1 may become 2, 2 may become 3 and so on. It can vary, right? Almost like n ways. Now next one. This is 1 comma n. Whenever recursion is going on, this n may becomes, right? N minus 1, maybe n minus 2, maybe n minus 3. Please check yourself and so on until 1. This is also n ways. So totally, what is the answer? N square distinct function calls. N square distinct function calls. Please check yourself. Right? Some people are asking, sir, in the one place how 2 will come? How 2 place 3 will come? How n place n minus 1, n minus 2? If anyone having small doubt also. That is the reason I done this numerical example. See this. See this one. First place is 1. 1 comma 4. 1 comma 4. First place 1. Whenever recursion is going on. First place 1. First place maybe 2 will come. See this. Whenever 1 comma 4 going on. First place maybe 3 also will come. First place maybe 4 also will come. All possibilities. Recursion will take a distinct only we are calculating, not all. First place 1, while doing this internally maybe 2 will come, maybe 3 will come, maybe 4. Next one, last place 4, whenever recursion is going on, last place 4 maybe comes, right? 3 also, 2 also, 1 also. That is the reason. This can change 4 ways. This also can change 4 ways. Right? That is the reason I done the example. Distinct function calls only we are calculating. So how many distinct function call? N square distinct function call. Next one, n square into 1 distinct function call will take how much time? Order of n time. You know, in this problem speciality is, right? One function cost is n. Previous all application, one function cost is 1. Here one function cost is n. So totally, what is the answer? N cube. N cube is the time complexity. Using dynamic programming, time complexity, big O of n cube. Right? This is with dynamic programming. With dynamic programming, time complexity, big O of n cube. Without dynamic programming, time complexity n power n. This is only n cube because distinct function calls we are calculating. Let's go to the next one. With DP, with dynamic programming, extra space. With dynamic programming, extra space. When you say with dynamic programming, what is the answer? Because of recursion, stack will come, right? Dynamic programming, stable also will come. Can you say what is the stack size? N level tree, so n byte. What is the table size? Table size is based on how many distinct function calls? N square. N square distinct function calls, so n square table required. So finally, n plus n square. What is the answer? Big O of n square. Space little bit increased. Previously, without dynamic programming, space is extra space is only n. With dynamic programming, right, extra space becomes n plus n square. Space little bit increased, but time decreased a lot. Without dynamic programming, time above only I written. Without dynamic programming, time. What is the answer? This is n power n. Right, extra space. What is that one? N. Only stack. With dynamic programming, distinct only we are calculating. Time becomes n cube. Actually, some people are thinking that time is n square. No, distinct function calls are n square. One function cost n, total time complexity n cube. With dynamic programming, extra space, right? Stack plus table. Because of dynamic programming, table will come. Table size based on distinct function calls. Stack is same as it is. So n plus n square, n square. Right? So please be careful. In this one, so many changes are happened. In this one, so many changes are happened. Previous all applications you see, this application you see. Previous all binary tree came. Here, right? N array tree came. Previously one function cost, previous all application, constant time. But here one function cost, order of n, because out of n people finding minimum. Previous all, out of 2 people finding minimum or maximum, constant. But here out of n people finding minimum, order of n. Previously binary tree, now here n array tree. Next one, this problem, great important thing is numericals only, mostly they will give. Numericals only. That is 5 examples I done. Those numerical examples, if you are okay, right, remaining thing is small story, writing the recurrence relation, distinct function calls, counting, and so on. Without dynamic programming, because of it, the n array tree, time complex almost like n power n. Space is, right, I think recursive program, stack space, extra space, right, extra space, what is the answer? N. Extra space is n, right, but with dynamic programming, distinct function calls only we are doing n square, one function cost is n, time complexity n cube. What is the extra space? N for the stack, n square for a table, total is n square. Please be careful, numerical examples very important, followed by time complexity space, right, extra space. Space means extra space only, right, because, right, that is I think input is going to be fixed part. When someone will ask you what is the space complexity definition, simply say, what will you say? Simply space complexity is nothing but input plus extra, right? But we will comparing the algorithm, we will compare only extra space only normally we will take into account. If anyone asks you what is the space complexity, say space complexity means total space you are taking. But when you are comparing two algorithm, we will compare only variable part. Fixed part is always same, variable part you will compare. Right? Fine. So that is the reason extra space only I written everywhere, because extra space only required to us. So I think with dynamic programming, without dynamic programming, time and space followed by those 5 examples, if you are comfortable, it is more than enough. For dynamic programming, I said many applications to you, right? Whatever I said, they are more than enough, right? Whatever I said, please cover all of them properly. Don't by heart. If you get one application properly, remaining all you will get. And one more, when you are practicing dynamic programming, please be careful, try to get the matrix chain multiplication clearly. If you get the matrix chain multiplication, indication that you got all other remaining things. Try to get the matrix chain multiplication without small doubt. That indication that you got all. After that, right, you can see all the things also. Otherwise, if you want, you can see from the Fibonacci series. But one thing, without by hearting, study all. If I left out anything, right, they may not came in the previous paper, that is the reason I left out, right. If you have time after completion of all, please read them properly from your side. Right? So I am not saying that whatever I left out, they are not important and all. Right? Whatever is there in the previous paper, I covered all. Right? If I left out anything, please cover by yourself after completing these. After completing whatever I done, after completing them, whatever I left out, you can go through it yourself. Right? I don't want to waste your time and my time also. Those people who completed meaningfully all, those only are eligible to complete the whatever things pending. Right? Whatever I am thinking really important, I said to you. Remaining, if you have time, you can find out. Right? It's okay. Now see the next one. See the next one now. Carefully listen this also. One small point is pending. Let me write this. See this one. Sorting algorithm. Sorting algorithms are 2 types. Sorting algorithms are 2 types. One is comparison based sorting algorithm. Comparison based sorting algorithm. Another one is without comparison sorting algorithms. Right? Comparison based sorting algorithm, without comparison sorting algorithm. Sorting algorithms are 2 types, with comparison, without comparison, indirectly, directly. Right? Next one. So some people are asking, with comparison sorting algorithm, without comparison sorting algorithm, it's okay. But what are the with comparison? Whatever you know, those are with comparison only. What are those? Bubble sort, right? Next one is going to be bubble, next one is going to be, I think, selection sort, insertion sort, bubble sort, selection sort, insertion sort. Next one, heap sort, merge sort, quick sort. Next one, can you help me now? These are comparison based sorting algorithm. What is the meaning? You will compare the elements. While sorting the array using any one of these, right? Compulsory you will compare the elements. See this one, best case, worst case, average case. You know very well, only for namesake I am writing. These are comparison based sorting algorithm, right? Whenever a bubble sort is going on, first element is first element, second element, third element, you will compare, right? After comparing, if required, you will swap. Selection sort also, first one is compatible with all other people, right? Whoever is the first minimum, you will swap with that person in the first one, right? I think you will compare. Insertion sort also, first insert, then compare with the previous people. Heap sort, right? Whenever build heap method is going on, you will compare. Whenever max CP5 procedure, right, you will compare. So next one, merge sort, whenever merge algorithm is going on, you will compare. Quick sort, whenever partition algorithm is going on, you will compare. You know all these things. Next one, can you help me now? Only for namesake, whatever you remember, you give. Best case, worst case, average case. Bubble sort, every case n square. Some special cases are there, already I said in the classroom notes, they are meant for only GATE exam. Right, outside GATE exam, bubble sort is going to be n square because bubble sort is a lightweight sorting algorithm. Means conditions are very less. Bubble sort is a lightweight sorting algorithm. What is the meaning? Conditions are very less there. Don't keep all the conditions in the bubble sort. Don't keep that. Bubble sort is a lightweight sorting algorithm. So every case n square. In GATE examination, any best case came. Right, I already said in your notes. Right, please go through it. Outside bubble sort is n square only. Selection sort every time n square, but it is better for, right, swaps. That is also there in the notes. Selection sort, right, sorry, insertion sort, best case n, remaining all n square. Check notes. Heap sort, every case n log n. Next one, merge sort, every case n log n. Next one, quick sort, what is the answer? Best case n log n. Right, average case also n log n, only for namesake in exam, right? Only for namesake, right? Worst case n square. So sorting techniques are two types: comparison based and without comparison. Whatever we know, they are comparison based only. All the sorting algorithms you know very well. Please go through it once, right? So in examination purpose only, right? Bubble sort best case becomes n. Please be careful. That is a special case. Right? So normally if you see the books, bubble sort contain every case as n square. Because the reason is that is a lightweight algorithm. If someone asks you in the GATE examination, can you make bubble sort best case as n? Yes, I can make. Right? In any pass, number of swap 0. Don't go further with this condition. Bubble sort best case becomes n. That is only for examination purpose. Right? Normally it is every case n square. Quick sort every one quick sort 1 or 2 cases, worst case n square will come. Right? Mostly every time it is n log n only. These are the things which you know very well. Now can you help me one small line now? These all are the comparison based sorting algorithm. Can you help me now? In all comparison based sorting algorithms, if you observe, can you help me now? Worst case time complexities. Comparison based sorting algorithm, worst cases. Comparison based sorting algorithm, worst cases, if you observe, no one contain less than n log n. Check. In all comparison based sorting algorithm, worst cases, right? Answer, if you observe, minimum one is n log n, less than n log n, no chance. Now I am repeating the note which is very very important. In all comparison based sorting algorithm, worst cases, best one is n log n, less than n log n, no chance. See. In all comparison based sorting algorithm, best cases, best one is n. In all comparison based sorting algorithm, average cases, right? Best one is n log n. You know very well, in one of the previous paper, this note is given. Please remember this note. See the note. See the note now. In all comparison based sorting algorithms, in all comparison based sorting algorithm, worst cases, best one is n log n. In all comparison based sorting algorithm, worst cases, best one is n log n. Who will give that? Maybe heap sort, maybe merge sort, right? These two things. In all comparison based sorting algorithms, worst cases, best one is n log n. Best one is n log n. Worst case time complexity, best one n log n. Who will give that? Heap sort and merge sort. They may ask, this is the note what they asked already in the previous papers. Right? This is the note what they asked already in the previous paper. They may ask in another way also. In all comparison based sorting algorithm, best cases, best one n. Best cases, best one n. Best cases, worst one n squared. I think more than n squared not required. Best cases, best one is n. Worst cases, best one n log n. Average cases, best one n log n. This is very, very important. Please be careful. Let's come to the next one. Sorting algorithms are two types, with comparison, without comparison. This is without comparison sorting algorithm. They are, right? One, counting sort. We are not done until now, right? Counting sort. Next one, two, radix sort. Three, bucket sort. Without comparison, sorting the array, three ways, right? Counting sort, radix sort and bucket sort. And one more, this one, remember everyone? Without comparison sorting algorithm, counting sort, radix sort, bucket sort, try to remember these three algorithms will take, right? To sort the array, order of n time, every case. These three algorithms will take, right? To sort the array, order of n time, every case. But some people are asking, if every case is n, then why you spoiled our life? Some people are asking, sir, with comparison, right? N square, n log n, n like that. Without comparison, right? Every case n, then why you spoiled my life by saying all? You may ask like that, right? Try to remember, these three will take time complexity order of n every case with some conditions. Some conditions are there. With conditions, time complexity order of n every case. Some people are asking, what condition? Counting sort condition is going to be array of n elements where every element is in the range of 1 to n, range required. N elements array, every element is in the range of 1 to n, then time complexity n. If n elements array where every element is in the range of 1 to n square, then time complexity n square. N elements in the given array where every element is in the range of 1 to n cube, then time complexity n cube. Counting sort time complexity based on range. Counting sort time complexity based on range. N elements are there, all elements are in the range of 1 to n, then time complexity n. 1 to n square, then time complexity n square. 1 to n cube, time complexity n cube. 1 to log n, all elements are in the range of 1 to log n, then time complexity n only. Because n elements are there. N elements are there, all elements are in the range of 1 to n, then n. 1 to n square, 1 to n cube, 1 to log n, time complexity n only, because elements are n, minimum n is there. So range, he is talking about range of the element. Think about counting sort, mostly will be the answer. Next one, see this next one, radix sort. Radix sort time complexity order of n with the condition, right? With the condition, n elements are there, all elements, if you go to the elements and if you verify, right, every number contain number of digits as constant. Array of n elements where every element contain constant digits, then radix sort time complexity order of n. Please be careful. I am repeating once again, array of n elements where every element contain constant number of digits, then radix sort time complexity becomes order of n. Please be careful. In the similar way, bucket sort also. These three algorithms will take order of n time complexity every case with some condition, right? Counting sort range required, radix sort every number contain constant number of digits. In the similar way, bucket sort also. Then one more thing I want to say to you. I didn't cover until now. I said little bit to you, and one more I am saying to you. Just to open the Coreman book, there is a one chapter, name is called a linear time complexity sorting algorithm. Linear time complexity sorting algorithm, which contain these three, which contain almost like 2 or 3 pages. Please go through it by yourself. Complex sorting algorithms I done see. I done quick sort, I done merge sort, I done heap sort. Almost like these 3 algorithms, if you observe, every algorithm contain one paragraph only. Please go through it. So you will see some 2 pages also, if you cannot read, how will you get the good gate rank? Something should be done by yourself. Intentionally I am giving. Otherwise I can do myself what is there in that, right? Some work I have to give to you. Then only, right? Then only you are improving or not. You can verify. 3 algorithms which contain in 2 pages only. In Coreman book, linear time complexity sorting algorithm, 2 or 3 pages are there. Counting sort, radix sort and bucket sort. Please go through it. They are very simple. One for loop or one while loop is there. Please go through it. I'm really saying to you, right? These 3 things will be done by you only. If you cannot do these 3 also, small things also, you are not eligible to get the good gate rank. Right? Please do take it as a homework. Right? These 3 things done by you only. Homework. I'm guiding you also. In the Coreman, topic name is linear time complexity sorting algorithm. Otherwise, counting, just type the counting sort. In the search option, just type counting sort or radix sort. Directly you will go there. I think 2 or 3 pages are there. Please read it. If you have any doubt, you can ping me. I will help you. This is the homework. I'm again and again I'm saying it is the homework. Any question came from these 3 areas, you have to take care. Only 2 pages are there. That too Coreman. Please read it. These 3 algorithms will take order of n time complexity every case. And one more, whenever these 3 algorithms are going on, no element is on. 2 elements are not compared directly. There may be a comparison, but 2 elements not compared directly. Some people are asking what is the meaning of comparing directly, indirectly. This may be the case. See this one. One element is 235. One element is 235. One more element is going to be assumed that 650. One element is 235, one more element is 650, right? So in those algorithms, in comparison based sorting algorithm, you may compare these 2 elements directly. But in the case of these algorithm, you may not compare directly. Indirectly maybe you will compare. How? Right? Can you help in this number? What the first digit? 0. In this one, what is the first digit? 5. You may compare this. Digits you may compare. You are not comparing the elements directly, right? So you are comparing the digits. You may be comparing digits, right? That is the reason it is called as, right? So without comparison sorting algorithm, you are not comparing elements directly. You may be comparing some other way. Digits maybe you are comparing, but the numbers you are not comparing directly. Please you take care. This is very simple. Only 2 paragraphs. I think one algorithm, 2 paragraphs. These 3 algorithms combinedly, there may be a chance that 2 or 3 pages are there. It is very simple. To get confidence from yourself, I given this homework. I given the source also. Coreman linear time complexity sorting algorithm, 2 pages. Right? Major things I completed. Small thing I given homework to you. If you say, sir, why you are not covering this? I have to give little bit of homework to you. Otherwise, you don't grow at all. Everything is right. Everything someone is teaching, you are reading. Someone is teaching, you are reading. Everything looks easy, right? But when you read your own, you will get the something what is going on. If you get little bit doubt also, you can ping me. Right? Fine. I'm thinking you are okay.